Hello there and welcome to your 10-1 notes on the Pythagorean Theorem. I hope you're feeling all right because by the end of the day you will be able to solve problems using the Pythagorean Theorem and to identify right triangles. Let's get started by recalling some definitions. So remember that a right angle has a measure of 90 degrees. That is, if you have an angle, you got two rays intersecting each other just like this, and they intersect at 90 degrees. We put a little chair there. It's like you've got this guy sitting there. He's got really long legs because I'm not an artist, I'm a mathematician. Anyway, so that's a right angle. However, if we were to take this guy, right, and then she's kind of like, wee, and squish him, we'll make him really tiny, and we're like, oh, so cute. Look at how squished he is. Oh, what a cute picture that is. An acute angle is one whose measure is less than. That's grammatically wrong. An acute angle has a measure less than 90 degrees. Also up here I put degrees. So there you go. Less than 90 degrees. So acute angles are ones that you draw and they look like this and you go, oh, that's a cute angle. Meh. Okay. That said, draw your best right triangle in the space below. Perfect. Okay. This angle right here is going to be the right angle. And the side across from it has a very special name. He's no hippopotamus, but he's a hypotenuse. Like hypo as in under, 10 as in 9 plus 1, use as in utensil. Hypotenuse. Okay, awesome. And then if you're not a hypotenuse, you're a leg. So the sides adjacent to the right angle we call legs. So this is a leg and this is another leg. Ta-da! Now, fun facts about triangles is the hypotenuse will always be the longest side of the right triangle, forever and always. This is always longest. This is because it's across from 90-degree angle, and the 90-degree angle will always be the biggest angle in a right triangle. If you want to know why, ask me in class. And then the legs are also always opposite acute angles. So those guys are always acute. Aww. So cute. So look at this triangle and see what we can say. See what we can see. Is it true that the hypotenuse is the longest side in a right triangle? Yes, that is always true. Is the hypotenuse of the triangle at the right, does that have a length of 12 centimeters? Well, the hypotenuse is always the longest side, which means this guy is going to be our hypotenuse. So this statement is false. It's not that the hypotenuse has a length of 12 centimeters, it's a leg of the triangle has a length of 12 centimeters. The legs of a right triangle can be any two of the three sides. That's not true. The legs of a right triangle have to be adjacent to the right angle. There. Perfect, I fixed it. The legs of a right triangle can't be just any two of the three sides, not just any. They have to be touching the 90-degree angle. They have to touch the right angle. Don't touch the left one. Anyway, a leg of the triangle at the right has length 16 centimeters. Is this a leg? Yes, this guy is a leg. This guy is also a leg, so that's cute. Yay, true. And finally, the hypotenuse of the triangle at the right has length 20. Is this the hypotenuse? That is the hypotenuse. So this is a true story. All right, sweet. Now we need to know what these are because if you take the length of the hypotenuse, that's equal to the squares of the other sides. So if you take a leg squared, and then you add that to the other leg squared, that will always be equal to the hypotenuse squared. Now that's really annoying to write. So instead, what we like to do over here in Math Magic Land is we like to draw ourselves a beautiful right triangle like this. I said we like to draw ourselves a beautiful right triangle like this. And then we call our hypotenuse length C. We call our legs A and B, just for funsies. And then we say that A squared plus B squared is equal to C squared. I would love to prove this to you, prove why we do it. If you really want to know, I'll do that in class. Okay, cool. Now, why is this important? Well, we can find distances. Let's say you aren't able to measure the distance across a river. Let's see, how would this work? I don't remember how I would draw this. If you don't know this distance, but you can figure out here and here, then you can use that to figure out that distance right there. Anyway, oh, I know, classic case. If you want to find how tall the tree is, oh, that's backwards. If you want to figure out how long the shadow is, and you know how, no, you know. Anyway, there's a whole bunch of maths we do to figure out how tall the tree is based on this length and stuff. Anyway, we'll get there. Hang on. Stick to the script. Here we go. What is the length of the hypotenuse if the lengths of its legs are 9 centimeters and 12 centimeters? That means A is equal to 9 centimeters. B is equal to 12 centimeters. So plugging that into our A squared plus B squared equals C squared, we get 9 squared plus 12 squared equals C squared. Whatever that is, well, that'll give us 81 plus 144 equals C squared. So 169 is equal to C squared. And then to solve for C, we just need to undo that square, taking the square root of 169. And we'll get 13. Technically, we get plus or minus 13, but we can't have a negative distance, so we go with the positive. So our answer is 13 centimeters. That's wrong. I lied. I can't add. Just kidding. It's 225. 15 centimeters. There you go. I was looking at example 2, where we use 13. Just kidding. Okay. A squared plus B squared equals C squared still works if we need to find the leg. This time we have our hypotenuse, sweet, and we have one leg. We need to figure out, shooties, what's the other one? Well, here we go. X squared, whatever that is, plus 12 squared equals 13 squared. So we get x squared plus 144 equals 169. I always get 13 squared and 14 squared mixed up. We need to subtract 144 from both sides. We get x squared equals 25, which means taking the square root of both sides, x equals 5. Cool, but 5 whats? 5 cats? 5 donuts? 5 miles? 5 light years? 5 parsecs? We don't know. We don't know the units. They didn't give it to us. So let's go with 5 donuts because that's funniest. Anyway, come back to me. Here we are. Now we can use the, what are we talking about today? We can use the Pythagorean Theorem even when it doesn't work. Here's how. So we've been operating under the assumption that a squared plus b squared equals c squared, but we can actually work backwards. We've been starting with a right triangle and then using a squared plus b squared equals c squared to find the distance. But if we know the distance, we can use that to figure out if it's a right triangle or not. What? Okay, example. Let's say you have side lengths 12, 16, and 20. We need to figure out, is this a right triangle? And remember, the hypotenuse is always the longest distance. That's going to be key. That piece of information is going to come in clutch, whether that is still relevant or not, okay? So we're going to set it up like this. Since 20 is our longest distance, it must be our hypotenuse. So we say, hey, is it true that 12 squared plus 16 squared equals 20 squared? Maybe? We don't know. Put a little question mark. We don't know. Well, what I do know is 12 squared is 144. And I do know that 16 squared is 256. And I do know that 20 squared is 400. And I also know that 144 plus 256 is 400. So yeah, this is a right triangle. So that's cool. Conversely, we want to check, and I just spoiled it. I'm not even sorry. Oh, well, okay. So here, if our side lengths are 9, 11, and 14, remember our longest side is always our hypotenuse. So we're going to plug, oh man, that's not true. That's not equal to 14, it's not even equal to 14 squared. There we go. So we plug them in. Is 9 squared plus 11 squared equal to 14 squared? Well, let's find out. Is 81 plus 121, is that equal, maybe, to 196? Well, I already told you and I spoiled it. It's not, because that's 202. Last time I checked, it's not equal to 196. It's close, but close only counts in horseshoes. And hand grenades is something that, I had a friend who used to say it, but I don't know if I'm allowed to say that to you guys. So, yeah. Anyway, not a right triangle because it doesn't fit the Pythagorean Theorem. Okay, so let's see. One last time. Are you guys a right triangle? Is this right? This doesn't feel right to me. Let's find out. Well, I like to draw pictures, even though apparently I'm not good at them. So let's make this awesome right triangle super duper. We gotta figure out which of these lengths is our hypotenuse and which are our lengths. Oh, shooties. There goes my awesome art skills. Can't even highlight. Alrighty. Now we know our hypotenuse is always our biggest side. So this guy is 52 millimeters. So 20 and 47 millimeters are going to be our other legs. So now let's plug it in. Is it true that 20 squared plus 47 squared equals, maybe, I don't know, 52 squared? Well, let's find out. Is it true that 400 plus 2209 equals, maybe, 2704? No, this is not a right triangle. This is a left triangle. I'm just kidding. It is a not right triangle. There you go. Okay, so Pythagorean Theorem says that if you have a right triangle with legs A and B and hypotenuse C, then its side lengths are a squared plus b squared equals c squared. And it also says that you must have a fantastic time on your homework.